Hello, boys and girls. Welcome to math class. I'm Mrs. Gibbs, and today we're going to be working on some measurement problems. So if you have a Bridges Math workbook, you can go to page 121. But if you don't, please just use pencil and paper and work out the problems right along with me. You can even pause the video at any time and try to work the problem and then come back and see if you were correct. So let's get started. Make sure you have some paper, a pencil, and a really great attitude because here we go. Okay, so you can see this problem says bird measurement problems. Solve the problems on this sheet and the next. Show your thinking using words, numbers, or sketches. A bird named Sal has a mass of 149 grams. Sal landed on a leaf next to a bird named Ted with a mass of 398 grams. How much mass do they have together? Be sure to label your answers with the correct units. So units in this term is talking about grams. So we want to make sure that we remember that we are working in grams. So we need to figure out how much they are together. So that means we're going to add the two numbers that we see. So we have 149 grams and and then 398. So 149 really neatly. And then we write 398 right under it, 398. Then we're going to add these together. Now that we have our problem set up, go ahead and pause the video and try this one. All right, let's see if you're correct. So 9 plus 8. Well, I know that doubles plus 1. 8 plus 8 is 16, and one more makes 17. So we're going to put down a 7 and carry the 1. 9 plus 1 plus 4. 9, 10, 11, 12, 13, 14. Okay, so you could do the different ways. I tried to make a 10 and then add the 4, or you can use text math, starting with the biggest number and then counting on the others. So again, there's a 10 plus 4, 14, put down a 4, carry the 1. 1 plus 1 is 2, and 2 plus 3 is 5. So we put our 5 in the hundreds. So together they have a mass of 547 grams. Pretty easy, right? If you wanted to use a number line to add, or if you used a different strategy, as long as you get to the answer of 547 grams, then you are correct. That's what I love about math, is that there's not just one way to do it. It's that you can pick the way that makes the most sense for your brain. Let's look at number 2. How much more mass? How much more? How much more? We're going to be comparing. How much more mass does Ted have than Sal? Be sure to label your answer with the correct units. So we're using grams. All right, so I'm going to go ahead and write grams right here. Don't want to forget. How much more mass does Ted have than Sal? So Ted, if I go back to the first problem, Ted has a mass of 398. 398. Sal has a mass of 149. 149. So because I'm talking about how much more, I need to find the difference between these two. Go ahead and pause the video and try this on your paper. All right, are you ready? 8 minus 9. Can't do that, so we have to regroup. So we're going to go to the 9 tens and change it to 8 tens. Then this 8 becomes 18 because we're adding 10 to it. 18 ones minus 9 ones is 9. 8 minus 4 is 4. And 3 minus 1 is 2. 249 grams. More mass than Sal. So Ted has a more mass of 249 grams than Sal does. All right, let's look at the third problem. Now we're switching and we're going to be talking about measurement with time. If Sal leaves his nest at 1:30 and flies for 2 hours and 10 minutes, so 2 hours, 10 minutes, what time does he come back? So we're at 1:30 and we're going to add 2 hours and 10 minutes. Okay, I'm going to do this 2 different ways. So If you would like to, you can pause it and try on your own. Or since elapsed time is relatively new at this point in our program, then you're welcome to just follow along right along with me. All right, so we're going to start at 1:30, and I'm going to draw my timeline here. So 2 hours, 1:30 to 2:30, 2:30 to 3:30. So I'm at 3:30, and then 10 minutes plus 10, and I'm going to be at 3:40. So right here, I've got 1 hour and 1 hour, and I just said 1:30 to 2:30, 2:30 to 3:30. So my time is 3:40. That is a timeline. Another strategy that's pretty simple to use is to start here. You're going to add your elapsed time. So I'm just going to put EL for elapsed, and then we're going to end with our end time. So we're going to have 1:30, and then I'm going to add 1 hour. That gets me to 2:30. Add another hour, and that gets me to 3:30. And then I'm going to add 10 minutes. I guess I should have labeled these, right? Don't forget to label. And now we are at 3:40, and that's our end time. Okay, so Sal comes back at 3:40, and I'm assuming that this is during the daytime. I don't usually see birds flying around at night. Usually they're already nestled into their nest. So I'm going to go ahead and just assume that it's PM, just because that makes sense to my brain. If Ted leaves his nest at 8:50 and flies for 30 minutes, what time does he come back? Why don't you pause this time and try one of the strategies we just talked about? Okay, are you ready? All right, 3:40. Oh, wait, not 3:40. Oops, 8:50. Just going to make that into an 8:50. 8:50 plus 30 minutes. Okay, so I'm going to need to count on. So if I think about 8:50 plus 10, that's going to get me to 9 o'clock. So I'm just breaking that 30 into a 10 and then a 20 minutes. So then I take 9 o'clock and I add 20 minutes, which would be 9:20. Again, AM, because now we're talking about in the morning time. It's usually dark around here, at least, at 8:50 in the evening. So Ted comes back at 9:20 a.m. All right, so this strategy was just counting on or adding. It's very similar to the T-chart. So I just went ahead and just wrote it out like that. You could have used the number line or just counting on in your head. I was just trying to show you my thinking. All right, so let's go on to the next set of problems on page 122. Number 5, Ted jumped into a beaker of water that held 313 milliliters of water. When he flew back out, there was only 189 milliliters of water. Remember that milliliters is a small unit of measurement, whereas the liters is larger. How much water had splashed out of the beaker? So we started with 313. Then he took a bath and splashed all around, and then there was only 189 left. So we need to figure out how much was splashed. So this was the beginning. This is how much splashed out. Or I guess we need to figure out how much is splashed, but we know that this is what he ended with. So I'll switch that. Sorry about that. Even teachers make mistakes. It's okay. And when we finish, when we find the solution to this, that will be how much he splashed out. Do you see what I just did? Goodness. Splashed. Okay, now we're finally ready. So 3 minus 9. So think about that. The bottom is bigger. Bigger bottom, better borrow. So we better go to the tens. 1 10, we're going to change to 0 tens. And then we're going to make the 3 into 13. Now this time I'm going to put 13 in my head and just count back until I hear myself say 9. Okay, so try that with me. 13, 12, 11, 10, 9. I know it's 4 because 4 plus 9 is 13. I can show you that strategy, just counting backwards. All right, and then to tens, 0 tens minus 8 tens is not going to help us complete this. So we're going to change the 3 to a 2 and borrow 100. And now this becomes 10. 10 minus 8 is 2. 2 minus 1 is 1. 124 milliliters splashed out. So 124 milliliters had splashed out of the beaker. So I took my starting number minus the number we ended with to find out how much we lost. Ted's nest has 3 times as much mass as Ted. How much mass does Ted's nest have? Okay, so in order for us to figure that out, we have to go all the way back to the first problem. And it said Ted has a mass of 398 grams. So I'm going to go right here to number 6, and I'm going to write 398 grams. That's Ted. His nest has 3 times as much. 3 times as much. It's right there in the words. 398 times 3. Okay, I can use the property of 0 to help me, like with multiples of 10. And the distributive properties. I'm going to show you what we're going to do. First, we're going to take and pass them out. So 300 times 3, that'll be one section. 300 times 3 plus, now we're going to look at the tens, 90 times 3. And then lastly, we'll do 8 times 3. So plus 8 times 3. Now that we've set it up like this, see if you can solve each one of these parentheses and rewrite the problem. All right, so 3 times 3 is 9. 0 times 3 is 0. And 0 times 3 is 0. So what the 0 trick is that you can multiply the numbers. And then if you're multiplying, however many zeros are in your problem are the zeros that you find in the solution. Let's look here. 9 times 3. 9 times 3 is 27. There's 1 0, so there it goes. 0 times 3 is 0. Plus 8 times 3. Row, row, row your 8s. 8, 16, 24. So if we sing our 8 song, then we know it's 24. Now, if you have these 3 numbers, now you're going to put them together. So I'm first going to start with 270 plus 24. So I know that 70 plus 20, 70, 80, 90 plus 4, 94, 294, 294 plus 900, which is just 1 away from being 1,000. So I know that this is going to be 1,194. 1,194, and we are using the unit of grams. You can also just put a G for the abbreviation. Okay, Sal's nest has 3 times as much mass as Sal. How much mass does Sal have? Sal's nest have. So we're going to do the same thing. So I'm going to go back and I'm going to look that Sal has a mass of 149 grams. So here we go. 149 grams. And his nest has 3 times as much, times 3. This time, if you want to use distributive property, go ahead and try that. But we're going to try another way that you can check your work is by adding this number 3 times to itself. 149, 149, and 149. Now, when we add and subtract, we start in the ones place. So 9 plus 9 plus 9. 9, 18, 27. Put down a 7, carry the 2. 4 plus 4 plus 4. Mary had a little 4, 8 and 12. So 12 plus 2 more. 13, 14. Put down a 4 and carry the 1. Then we add the hundreds. 1, 2, 3, 4. 447 grams. Now we write it right here. Sal's nest has a mass of 447 grams.